Hello and welcome to the final video of Section 3, Desktop Design Considerations. In this video we're going to spend some time looking at how to design and build the virtual desktops within your environment and the infrastructure that's needed to support them. So let's start by defining what is a desktop pool. Here we have three pools, each containing a number of virtual desktop machines. At a high level, a desktop pool is made up from a group of virtual desktop machines that have the same attributes. So which attributes? We're going to look at the attributes in 4 dimensions, with the first of these attributes being defined on a departmental basis, where the desktops in each pool are configured for each of the specific departmental requirements. In this example, we have 3 departments. We have marketing, we have sales, and we have engineering. Each of the departments have different requirements for their virtual desktop machines. So the next attribute we're going to look at is based on the hardware configuration of each of the virtual desktop machines within the pool. Each of the virtual desktop machines within a pool could be configured with a different hardware config. For example, engineering could have access to an NVIDIA graphics card. Maybe they also have 4 virtual CPUs and more memory than virtual desktops in other pools, whereas the virtual desktop machines in the sales pool all have a single virtual CPU, and those in the marketing pool have 2 virtual CPUs. The next attribute we're going to look at is for the applications. Here, you can have different applications installed on the base image of each desktop within a pool. For example, the virtual desktop machines in the sales pool might have Excel installed, and the virtual desktop machines in the marketing pool might have PowerPoint installed. There is of course another way to deliver applications within virtual desktops where you don't need to install them in the base image at all, which would potentially mean you would not need to have a desktop pool based on just applications. We are of course referring to application layering, whereby an application gets delivered to the desktop on demand when the user logs in. App layering is out of scope for this particular course, however please look at the VMware App Volumes course, also published by Pact Publishing. Finally, the last attribute we're going to talk about is the operating system. Like with applications, here you could have different operating systems running on each of the virtual desktop machines within a pool. For example, the virtual desktop machines in the sales pool might be running Windows 7, and the virtual desktop machines in the marketing pool might be running Windows 10. As you can see, we've created different pools for different departments, configured with different hardware specs, different apps, and even different operating systems. There are a couple of additional dimensions that we're going to cover next, and that's how the desktops within the pool are built and delivered, and whether the virtual desktop machines are persistent or non-persistent. We're going to start with the different pool types. There are 3 desktop pool types: automated, manual, and RDS. Automated desktop pools, as the name might suggest, automates the building of a virtual desktop machine within the pool. They are created from either the snapshot of your gold image or from the template that is created of your gold image. Virtual desktop machines are built on demand. That is when a user logs in and requests a virtual desktop machine. Or View can pre-build desktops up front, so there is always a buffer of desktops available for when users log in. This is something you would typically do ready for peak logins, such as first thing in the morning. The manual pool allows you to connect to existing virtual desktop machines or even physical desktop machines, just so long as they're running the Horizon agent. And the final desktop pool type is for RDS. This allows you to build a pool of session-based desktops that are delivered from the RDS platform. That leads us on to the next question: persistent or non-persistent desktops? We're going to talk about the different types of desktop assignments and the way in which a virtual desktop machine is delivered to an end user. This is an important design consideration, as the chosen method could potentially impact on the storage requirements, the hosting infrastructure, and also which technology or solution is used to provision the desktop. One of the questions that often gets asked is whether you should deploy a dedicated or persistent assignment or a floating desktop, a non-persistent assignment. Desktops can either be individual virtual machines which are dedicated to a user on a one-to-one basis, as we have with a physical desktop deployment, where each user effectively owns their own desktop, or a user has a new, vanilla desktop that gets provisioned, built, personalized, and assigned to them at the time of login. The virtual desktop machine is chosen at random from a pool of available desktops that the end user is entitled to use. The 2 options are as follows. With persistent desktops, users are allocated a desktop that retains all of their documents, applications, and settings between sessions. The desktop is statically assigned the first time the user connects, and then is used for all subsequent sessions. No other user has access or is permitted to use that desktop. With non-persistent desktops, users might be connected to a different desktop from the pool each time they connect. Environmental applications or user data does not persist between sessions and is instead delivered as the user logs on to their desktop. The desktop is refreshed or reset when the user logs off and returned to the pool for the next user. In most use cases, a non-persistent configuration is the best option. And the key reason is that in this model, you don't need to build all the desktops up front for each user. You only need to power on a virtual desktop as and when it's required. All users start with the same basic desktop, which then gets personalized before delivery, which helps with concurrency rates. For example, you may have 5,000 people in your organization, but only 2,000 ever log in at the same time. Therefore, you only need to have 2,000 virtual desktops available. Otherwise, you'd have to build a desktop for each one of the 5,000 users that might ever log in, resulting in more server infrastructure, a lot more storage capacity, licensing, and so on. The one thing that used to be a bit of a showstopper for non-persistent desktops was around how to deliver the applications to the virtual desktop machines. You ended up, as we saw in the earlier example, having to have different pools to reflect the different application requirements, or worse still, having to install every single application into the gold build. Again, licensing nightmare. Now that the application layering solutions such as VMware App Volumes or Liquidware Profile Unity with FlexApp are becoming more mainstream, the applications can be delivered on demand as the desktop is built and delivered to the end user. Another thing that we often see some confusion over is the difference between persistent and non-persistent desktops and how cloning fits in. Just to make it clear, linked clones, full clones and instant clones are not what we're talking about when we refer to dedicated, persistent and non-persistent floating desktops. Cloning operations refer to how a desktop is built and provisioned, whereas the terms persistent and non-persistent refer to how a desktop is assigned to an end user. Dedicated and floating desktops are purely about user assignment and whether a user has a dedicated desktop or one allocated from a pool on demand. Linked clones, full clones and instant clones are all features of Horizon and VMware vSphere infrastructure that create a desktop image for each user from a master or parent image. This means that regardless of having a floating or dedicated assignment, the virtual desktop machine could still be a clone, linked clone or instant clone. The following table shown on screen is a list of some recommendations for base desktop sizing collected from a number of different VMware documents. Obviously, the resource required for the desktops will be greatly affected by the applications being used within the desktops. In this section, we've already covered some of the high-level host server considerations, but now you have an idea of what desktop resources you need to deploy. You can go to the next level of detail and look at things like clock speeds of CPUs and determine how many hosts you will need, along with RAM requirements and disk requirements. One of the most asked questions when sizing the servers that are hosting the virtual desktop machines is, how many can I fit on each host server, or how many virtual desktops can I have per core? Not to want to sound repetitive, but the answer is, it depends. Firstly, it depends on the CPU resources that your desktops are going to consume, and the answer to that question will only come from your assessment data. Secondly, and more obviously, it will depend on the CPU you configure in the host servers. This is usually chosen on a price-performance basis, as there is usually a CPU that makes more financial sense and the best cost per desktop model. For this section, as we don't have any actual assessment data to work from, we will use some assumptions on the types of users and CPU requirements for each type of user, just so we can give you an example to work with. The users are then grouped into light, medium, and heavy usage. We will base our calculations on a standard rack mount server, configured with two Intel Xeon processors running at 2.6 GHz and have 10 cores per CPU. And that gives us a total of 20 cores per host server. In the example calculations, you will also notice that we've subtracted 2 of the cores from the total available cores on the host server. The reason we've done that is for the hypervisor. Don't forget, we need to give VMware ESXi its own resources. Let's take a look at a light user with a typical utilization of say around 300 MHz of CPU resource. It's also worth adding some additional resources to cover any peaks in workload and also other tasks such as sound or USB devices. And for this example, we'll add 10% to the 300 MHz figure. The profile of this user type would be somebody working in a call center, an admin person, or a basic web browser. These desktops might be suspended for long periods of time and have very low utilization, running just 1 or 2 light applications. We can work out the CPU requirements with the following quick calculation. We take the CPU speed in megahertz, we multiply by the number of cores, minus the 2 that we use in the hosting infrastructure, and we divide by the CPU requirements of each virtual desktop. So we have our 2.6 gig, we have our 18 cores, and we divide by the 330 MHz each desktop requires. And that gives us a figure of approximately 141 desktops per server. If we move to a medium user, here we have a typical utilization of around 500 MHz of CPU, plus we'll add our 10% again. This type of user would be somebody like a data entry person, or a doctor or a student, standard office user, or a help desk operator. The desktops will mainly be used during business and office hours and not particularly heavily utilised. Again, we can work out the CPU requirements with the quick calculation. So in this example, using the standard server described, you can host around 85 desktops per server. This breaks down to around 5 users per core. If we look at a heavy or a power user, with a typical utilisation of say around 750 MHz plus our 10%, this type of user would be somebody like a developer or a systems admin, an IT person, database admin, or an engineer. These desktops will be more likely heavily utilised throughout the day and also possibly used after business hours. They may also be running more graphically intensive or Java-based applications that will increase the utilisation of the desktop. Again, we can work out the CPU requirements using our quick calculation. In this user scenario, using the standard server, you can host approximately 65 virtual desktop machines. That gives you roughly 3 users per core. Sizing the memory for these servers hosting the virtual desktops machines is somewhat easier than CPU, although you might need to play a balancing act between the chosen server. The reason is that just because it can accommodate the number of desktops from a CPU perspective, it might not have the memory capacity to serve that number. If you take a virtual desktop that requires say 2 GB of memory, and look at the user scenarios we just covered as an example, you'll be hosting 141, 85 or 56 virtual desktop machines. That means that the host servers will need 282 GB, 170 GB or 112 GB of memory respectively, just to host the virtual desktop machines, plus of course enough memory to run the hypervisor itself. Depending on your choice of server hardware, you might not be able to configure this amount of memory, or it might be too expensive, in which case you might end up deploying more but lower configured servers. The key to a flexible desktop design is being able to build and customize the desktop in layers. Layers in this context is delivering the individual component parts of the desktop, such as OS, persona, as well as the applications. By achieving this, the desktops can not only be more flexible to allow one base image to be used for many users or pools, but also allow you to configure more linked clone or instant clone desktop pools. The following image depicts a user's desktop, where all the key elements are being controlled and managed. Your base layer will consist of an optimized OS configured to the needs of your business. Agents such as the Horizon agents and antivirus will be installed into this base image along with any applications. You will need to make a decision as to what applications should be installed in the base image and which ones are going to be delivered by some other mechanism. Often the applications that will get installed into the base image will be applications that are used across the organization, or a complete pool, such as Office or a PDF reader. You will also want to consider the nature of the application. If the application is unable to be virtualized with something like ThinApp as it contains drivers, or maybe integrate with a shell, these applications will also need to be installed in your base image. You need to have also built an application delivery strategy. This would detail how each application is going to be delivered to the end user. Some applications will be delivered as part of the base OS, whereas others will be packaged. Finally, let's look at delivering the persona, or the user's profile. Think of the persona as everything that makes the desktop personal. For example, application settings, the contents of my documents, icons, backdrops, etc., etc. There are a number of ways to achieve this, including redirected profiles, group policy, view persona management, or VMware UEM. There are also third-party products, such as Liquid Web Profile Unity. Wherever possible, keeping the solution as simple as possible and not having to combine third-party products is often the easiest way to reduce the management overhead. However, depending on the levels of customization for your users, you might need to introduce some of the products mentioned. There are a number of elements that you need to ensure are backed up when it comes to Horizon View, and we've summarized these in the following. You need to back up things like the View connection servers, the security servers, Microsoft LDAP, which is used to information across the connection servers, the View Composer database is key, vCenter, file servers that contain application information or View persona information, your gold images, and full clone or persistent desktop images, templates and snapshots. When it comes to DR, we need to look at the user's personas, ThinApp applications, again your gold images, full clone desktops, and your application layers. So that now brings us to the end of Section 3. In Section 4, we're going to start the installation of our VMware Horizon environment.